Morning. Okay. So tonight on Wednesday, you've got section 6.1 and 6.2 due. We've lectured over both of them. Good morning, Rich. Everybody's here. Woohoo. Saturday, your review for exam 3 is due. Again, the exam reviews are twice as long as the actual exam, but the way I created them is I made the exam first, and then I went to the review and picked out very similar problems and added extra ones in. And then on Sunday is that next exam. 2 of you have gotten your exam scheduled. The other 2 need to get that exam scheduled. You have to have it taken by Sunday at 11:59, so make sure you go to Proctor and get it scheduled. And then tomorrow what we're going to do is just have an office hour. So I will be here as normal at 9 o'clock to answer questions. You do not need to sign in, and I am not going to take attendance. But if you have specific questions, please log in by 9:20. If nobody's shown up, I will log out. So just so you know, I'll be here, but I'm only going to give you 20 minutes. So, but if you have questions, I'll stay here the whole hour. So what we're going to talk about today is actually the exam itself. We're going to go through some problems. And again, I need feedback from you guys. I'll be waiting for answers from you guys and so forth. It still has the exam itself. You get the 60 minutes. And there are 13 questions, which seems to be a good length for the class. It covers all of chapter 5, and then just section 6.1 and 6.2. So it's a little bit of the stuff that we've been doing this week. So what I want to start off with, and these are in absolutely no order whatsoever, so they're not in the same order as the exam itself. I'm going to kind of do it in the order that we kind of lectured in. So we started off by finding zeros. So our first example, I want to determine, and I would number them, but I have a feeling that I'll mess up on the numbers. We'll call it number 1. Determine if x plus 3 is a factor of x to the 4th minus 2x squared minus 15. So this goes all the way back to section 5.5, somewhere in there. So I want to know whether or not this x plus 3 quantity is a factor of this polynomial. Okay, so what is the problem asking me to do? What should we do?
Factor in x plus 3 to the equation.
So multiply it by x plus 3?
That would be my guess.
Okay, somebody else? Like I say, you're talking, Christina, but I can't hear you.
Is it synthetic division?
Yes. So we're going to come and use synthetic division. And what we're looking for is a remainder of 0. So we're going to use -3 in the box. Then we'll pick up our coefficients. So I would have 1. There is no x cubed, so don't forget the 0. And we have -2. There's no x term, so I have a 0. And then I have -15. Okay, we're going to bring down our 1. -3 times 1 is a -3. -3 times -3 is 9. It's going to give us a 7. -7 times that -3 is a -21. And -21 times a -3 is a positive 63. And I don't know what that comes out to be. That would be 53. So 48. Positive. Okay, so because this is not 0, it is not a factor. So that's all we care about. So the answer to the question is no, it's not a factor. An alternative way of doing this is if we had labeled this as f of x, you could have come in and found f of -3. You'll get that same answer, which is still telling you it's not a factor. So either synthetic division, and I think, Rich, this is what you were talking about, you can plug the -3 into the function. As long as the remainder is not 0, it's not a factor. So, okay. So something like that. Then number 2, what we want to do is find the zeros. And we're going to do f of x equals 2x to the fourth minus 13x cubed plus 19x squared minus 27x plus 9. So we have 2x to the fourth minus 3x cubed plus 19x squared minus 27x plus 9. Just going to ask you to find the zeros. Okie dokie. These are the long problems. What should we do?
All of P over all of Q.
Yep, let's go take a look at what P over Q is. That's going to give me an idea of what kind of numbers to try in my synthetic division. You're right. So P over Q. P is always the last one. So what are factors of 9?
1, 3, and 9.
Good. And then Q is always the first coefficient, and factors of Q are just 1 and 2. Okay, so now we need to make that into a list. So what have I got? I've got 1, and then I have 1 over 2, which is a half. We then have 3 over 1, which is 3, and then 3 over 2, which is 3 halves. 9 over 1 and 9 over 2. So those are the only numbers that are rational numbers where this thing can cross the x-axis. Okay, now what? What's our next step?
Synthetic division with all our zeros.
Yeah, and how am I going to figure out which numbers to try? Should I try just all of those until I find one that works, or is there something we can use technology-wise that will help reduce that? How about we graph it on our calculator? So we're going to say from the graph on the calculator. So, and that's the key to making this thing shorter. And this is why you have a graphing calculator for a class. And this is why you get to use the graphing calculator on the exam. It's for this one question. Okay, so after you graph it, can somebody go graph it really quick? Does anybody have their calculator with them? I have mine. So we'll go graph it. Let's clear that one out of there. X to the 4th. 3x third plus 19x squared minus 20x plus 9. The graph looks something like that. So it's very narrow and very thin. It's only crossing in 2 places, so that tells me that 2 of the 4 zeros are rational numbers, and the other 2 will be complex. So I know at the end I'm going to end up with complex because of that picture. Okay, let's leave the one that's on the left side alone. This guy over here, we can see is at x equal to 1. So we're going to go use 1 in our synthetic division. So I have 1, 2, -3, 19, -27, and 9. Okay, so you go through and do it. Give you a second to do it. Does it work? Yay, and we know it works because we get that remainder of 0. So, okay, now this other one is obviously less than 1. So if I come up and take a look at my list, the only number that is less than 1 is the 1/2. So I'm letting that list help me identify that 0. So now we're going to come in and use the 1/2. And that should take us to our quadratic. So again, we started off with the 4th degree. This line represents a 3rd degree. So now we're going to come down to the 2nd degree. So we'll bring down our 2 and go through it again. And sure enough, we get a 0. So that's the proof that we've got a 0. Okay, what's left down here is our 2x squared plus 18 equal to 0. So 2x squared plus 18 equal to 0. Now we can just go solve that. So we'll get 2x squared equals a negative 18. X squared is going to be a negative 9. So x equals plus or minus 3i. So then to summarize it, so that we have all our answers, our zeros are 1, 1/2, positive 3i, and a negative 3i. So 4 zeros, just like we were expecting. Okay, any comments about that?
Where did we find 3i?
That's coming from the square root of the negative 9.
Oh, okay.
So, anybody else? Okay, now because I have to go with the questions that are pre-written, the last part of this question is going to ask you to write the polynomial in factored form. Okay. So I'm going to call it a new problem, even though it's not. So we're going to write f of x in factored form. And again, that's from number 2. So take the polynomial from problem 2 and write it in factored form. Okay, so for us, I'm going to take each one of my zeros and rewrite it. So f of x is equal to, we're going to have an x minus 1 from that positive 1. I have to remember that because the coefficient on f of x was a 2, I have to recreate that 2. So I'm going to call that 2x minus 1 instead of the x minus a half. So again, that's the same thing. If you solve this, you'll get that 1/2. Then we have an x minus 3i and an x plus 3i from the 2 complex answers. So, and that's the polynomial written in factored form. So, okay, comments or questions? And it's only because I can't take parts of problems that I had to use that. So, I don't care for it myself, but sometimes I'm stuck. Okay, is everybody okay with the polynomial, solving them, or do you want to do another example?
I'm okay on them.
Okay.
Yeah, I'm
Everybody else
okay on
okay?
it.
Yeah, I'm good.
Okay. We'll move on. Okay, so question 4. We want to find a polynomial function that might have the given graph. So this time they're going to give us a picture. This is -1, this is -1, this is 1, and this is 2. So we have a point on the x-axis at -1, +1 and 2, and you have a point on the y-axis at -1. And it comes in and does something like this. And that's a bounce right there. So they gave me the picture, and now I have to figure out what it looks like. Okay, so we're doing the same thing we just did. We're going to write the polynomial in factored form. What we do have to remember this time is that we have to adjust for that leading coefficient. So we're going to put a dummy variable a out there. Okay, then let's come back in and pick up our factors. So that -1 that's an x-intercept is coming from what is a factor?
X plus 1.
Beautiful. What about that +1 that's a x-intercept? That's going to come from?
X minus 1.
Beautiful. And because the graph is bouncing there, what are we going to do about an exponent?
Squared.
Squared.
Make it even. Go for the easiest one. Don't make it harder on yourself. Okay, and then finally that 2 is going to come from what is a factor?
X minus 2.
Beautiful. Okay, so all we have to do is find a, and to find a, so find A, we're going to use the y-intercept. So in this case, the y-intercept is 0, -1. So we replace all the x's with zeros. So 0 + 1, 0 - 1 squared, and 0 - 2, and set it equal to the y-intercept with -1. So -1 equals A, that's a 1, that's a -1 squared, and a -2. Be very careful. Usually it's a little sign error. So that -1 squared will be positive. The 1 times the -2 is going to give me a -2. So then A is going to be equal to 1/2. So I've now found my leading coefficient. So that tells me that this thing's narrower than it would normally be. Okay, so then the polynomial then would be f of x equals 1/2 times x minus 1 times x plus 1 squared. Whoops, sorry, I just switched signs on you. Don't do that. And x plus 1, x minus 1, and x minus 2. So, and there it is. Okay, comments or questions about that?
Nope, I'm good.
Yay! Okay, moving on. The number 5, can we graph a polynomial without the calculator? And I'm gonna know whether or not you use your calculator because of that scratch work. So I want to graph f of x, oh sorry, g of x equals a -3x cubed times x plus 2 squared times x minus 1 to the 4th. So that's a -3x cubed times the quantity x plus 2 squared times the quantity x minus 1 to the 4th. Okay, and on the exam itself, it walks you through this in multiple steps. So it asks about the end behavior. Okay, so for us, if we were to multiply this all out, this would be a -3x to the, and now I'm going to add my exponents. So 3 + 2 is 5, + 4 is 9. So normally odd functions start below and end above, but this one flips that because of the negative out in front. So it's going to start above and end below. So our end behavior. And what they're asking for is the graph behaves like what? In this case, it behaves like a -x cubed. So but again, if on your work you're doing this, then I don't care what you type in there because I'll catch it off of this. That's why sending that work is so important to me. Okay, what about the x-intercepts? Okay, so what are our x-intercepts? So this x cubed that's sitting out in front comes from 0, 0. We have another x-intercept at -2. And the last x-intercept is at +1. So 0, 0, -2, and +1. Then they're going to ask you the zeros are, which are the same thing. And then it says, okay, now we're going to talk about whether it's bouncing or crossing. So, so at 0, 0, because it's an odd exponent, we know it's going to cross. The -2 is an even exponent, so we know it's going to touch. Same thing with the 1, 0, it's going to touch. Okay, y-intercept. What's my y-intercept? How do I find my y-intercept?
Set that x is equal to 0.
Yep. So if all my x's are zeros, then I'm going to have y is equal to a -3 times 0 cubed. And that right there is going to make everything else after it kind of pointless because 0 times anything is 0. So our y-intercept is at 0, 0, which we kind of already knew because it's sitting right here. So nice. Okay, and that's really all you need to go graph it. So they are going to have you evaluate a couple more numbers. So you can do that just on your calculator. But okay, let's see. We've got 0, 0. We've got -2. and a positive 1. Okay. We know the graph has to start above, so it comes into that -2. According to us, it's going to touch. So we're going to bounce and come right back up, get pulled over to the y-intercept where it has to cross. Get pulled back to the positive 1 where we said it's going to touch. And then it's going to come on down. So it looks something like that. And again, we can't tell these peaks and troughs. We don't know where they're at. So, and that's your polynomial function. On the exam, it's actually a multiple choice graph. So you just have to pick which one matches your information. So, okay, comments or questions about the polynomials? I think that's all of the polynomial stuff. So,
No.
good. Yay! We've done a lot in the last 3 weeks. Okay. Okay, let's come in and this is, I think, number 6. Let's come in and graph a rational function. So that would be something like h of x equals x plus 3 all over x squared minus 2x minus 15. So I want to graph h of x equals x plus 3 over the quantity x squared minus 2x minus 15. So there's nothing goofy about the rational functions. They're pretty straightforward. We just have to know the steps. So we need our x-intercept. Do you remember where the x-intercept comes from? We just talked about this last week.
Set it equal to, or replace h of x with 0 and solve.
So that would give me the y-intercept. So your first
yeah.
instinct was correct. Set it
Right.
equal to 0.
Right.
And because when you set it equal to 0, this denominator would multiply over here and give you also 0. All we need to do is set the top to 0. So set the numerator to 0, and we can get a, what, -3? Is that?
Yes.
Okay.
Yeah.
Actually, you know what? I think I have an issue here. We're going to have to change the sign. You'll see why in just a second. Okay, what about the y-intercept? You said it replace all those x's with zeros. What are we going to get? If all the x's
-5.
are zeros. Yeah, we're going to get 3 over -15. So a negative
Oh, yeah.
1/5.
Yeah, 1/5.
Okay, the next step is the vertical asymptotes. Where did they come from?
Is it the bottom?
Yep. It's the domain. So in other words, where does the function blow up? So to do this, we're going to come in and factor the denominator. Okay, don't write this down because I made a mistake here. If you factor this, doesn't this factor into x minus 5 and x plus 3? Factors of 15 that subtract to 2 or 5 and 3. And you see that this factor is the same as the one in the numerator. That creates a hole, and I would not do that to you on an exam. So what I'm going to do is make that a positive 2. It does not change either of these pieces of information. It is going to change the sign on that factoring and make everything work. So x plus 5, x minus 3, and an x plus 3 in the numerator. So that takes care of it. Just make it a plus 2x, and then we're good to go. So where are my vertical asymptotes then?
-5 and then 3.
Yep, exactly it. So -5 and 3. Then we need the horizontal asymptotes. That comes from the degrees. So in this case, the degree on the bottom is bigger, so it's bottom heavy. And when it's bottom heavy, that means it's the x-axis, so it's a line y equal to 0. If the degrees are equal, then it's the ratio of the coefficients. If it's top heavy, then it's an oblique or slanted asymptote, which we didn't do. So we only did one and that was it. So it wouldn't be on the exam. Okay, that's all our background information. Let's go figure out what we've got. So -3, -1/5, a vertical asymptotes at -5. And another one over here at +3. Looking to see if that shows up okay. Yeah. The horizontal asymptote sitting on top of the axis. So again, the horizontal only describes the end behavior. It doesn't tell me anything about the middle. So, okay, and that's our picture. So I'm going to go to the middle because I can see stuff going on there. I know I have to go through this point, and I go through this point. There are no multiplicities that are even, so everything has to kind of cross when it does it. So we're going to come in, we're going to cross at the x-intercept, head over to the y-intercept, and then head on down. How do I know it's not going back up? Because there's no other x-intercept to pull it back up. So it has to be doing that S shape in the middle. Okay, so because the graph is below on this side of the asymptote, then it has to be above on this side of the asymptote. Because the graph is above right over here, we know it has to be below over here. And again, that's the multiplicity telling me that we're going to be bow tying this wherever we're at. So, and there's our picture. Any comments or questions about the rational function?
No.
Nothing.
So that looks like it's also multiple choice matching. So in other words, they're going to ask you for the information, and then the picture itself is going to be a multiple choice. So you do have one where they're going to give you the picture and just ask you to read the information off the picture. So is everybody comfortable with that? In other words, if I gave you that picture, could you come in and tell me what the x-intercept and the y-intercept and the asymptotes were?
Yes.
Okay. Because yeah, you'll have one where you're going backwards like that. So, and again, if you have a horizontal, you do not have an oblique. So you can't have a slanted one if it has a horizontal one. It has either one or the other. So, okay, and then we're almost done with chapter 5, believe it or not. The other thing that came out of chapter 5 are the inequalities that were in 5.4. So number 7, I want to solve the inequality. So I'm going to do 2x cubed minus 5x squared minus 12x is less than 0. So 2x to the third minus 5x squared minus 12x is less than 0. Okay, so this was out of section 5.4. This one's a little obnoxious because it's not factored. So we're going to have to come in and the very first thing we're going to have to do is factor it. The one on the exam is already in factored form, so this is a harder problem. Okay, well, the first thing I can do is pull out an x. That's going to leave me with 2x squared minus 5x minus 12. And then we'll factor that trinomial that's sitting on the inside. So let's see, I get a 2x and an x. Factors of 24 that subtract 5 are 8 and 3. So I'm going to put the 4 there, the 3 there. That's going to be the negative, that's the positive. Oops, sorry. So I have x times 2x plus 3 times x minus 4 is less than 0. Again, on the exam, you're going to start here. You're not going to have to look at it from this point of view. Okay, and then if you remember, we did a sign chart, but we don't need the full-blown sign chart. We just need to know where it's starting and stopping and what the behavior is. So we're going to do an abbreviated sign chart. So the boundary numbers are the zeros. We have a 0 coming from here. We have a negative. Yes.
Is it, don't we need negative 24? Isn't it negative 8 and 3?
Yeah, so the 2 and the 4, yes. So I see where you're headed. So yeah, so I have a negative 24, and the factors of 24 that give me a negative 5 are a negative 8 times a positive 3. So the negative 8, let me get rid of that. The negative 8 is sitting here between this 2 and that 4, and then the positive 3 is sitting here between the 3 and the x.
Oh, okay.
Okay, so it's that leading coefficient of 2, and we've not done a lot of those, and that's part of what's coming back to bite us here. that leading coefficient of 2 is important. So then our zeros, we've got a 0 from the x. From that first factor, we'll have a -3/2, and from the second factor, we'll have a +4. So now I'm going to go to a number line. Make sure you get them in numerical order, because that's the biggest mistake here. So I have -3/2, I have 0, and I have 4. Okay, well, this is a cubic. We know that in general, cubics start below and end above. So if we were to graph this thing, it would do this kind of shape. So what we're saying is it's below over here. It's above between -3/2 and 0. It's below between 0 and 4, and it's above between 4 and infinity. So the inequality is asking us, where is this thing less than 0? So we're going to pick the regions. Where the graph is below. And that's because it's negative. If that had been a positive, I would have had to pick the regions where it's above. So then the answer to the question, we're going to go from -infinity to -3/2. We're going to use a parenthesis because the inequality doesn't have an equal to on it. And then we're also going to go from 0 to 4. So. Okay, comments or questions about that?
None.
Okay. Okay. And that's everything out of chapter 5. Yay! Okay, then you move into chapter 6. And it's only 2 sections out of 6. So. So problem 8, we're going to let f of x equal x squared, and we're going to let g of x equal 1 over x. We want to find each of the following. So for part A, we're going to do f compose g of 2. So again, this was section 6.1, the compositions that we did. So f of x is equal to x squared. G of x is equal to 1 over x. And we want to find f compose g of 2. Okay. So what do I do first?
Plug 2 into g of x.
Beautiful. We're going to go find g of 2. So that would be 1 over 2, or 1/2. And then what do I do with that? Take that answer and plug it into
F of x.
yeah. So now we're going to go find f of 1/2. So that would be 1/2 squared. And because there are no signs separating terms, it's just a single numerator, a single denominator. You square everything. Square 1, you get a 1. You square 2, you get a 4. So the answer to the question is 1/4. Beautiful, nicely done. And again, this is the homework that's due today, so it's probably not, if you haven't done it yet, you haven't done it yet. What if we do g compose f of -3? So g compose f of -3. Okay, somebody else tell me what I need to do first this time. So I need to go find what?
F of -3.
Beautiful. So we'll go find f of -3. Again, notice that we're starting at the tail end, the right side. So f of -3 would be a -3 squared. And a -3 squared is 9. And then what do I do with that 9?
Plug it into g of x.
Yep. So then we're going to go find g of 9, which would be 1 over 9, which is our final answer. 1 over 9. So, nice. Very nice job. And then again, because I cannot pick and choose parts of a problem, I have to pick the whole problem. So part C, let's go find F compose F of, I don't know, let's do -2. So F compose F of -2. Okay, so what are we doing first this time?
F of -2.
Yep, we're gonna go find F of -2. Again, that's starting at the right side. So a -2 squared is gonna give me a +4, and then we're gonna find F of 4, because again, we're taking that answer and plugging it back into F. So that would be 4 squared, which is 16. So our end result is 16. Any comments about that?
No.
I'm good.
Yay! Okay, and then we're going to go do the same thing, but with functions themselves, not numbers. We're going to evaluate functions at functions. So number 9, we're going to come in, and this time let's let f of x equal, we'll stick with x squared because it's easy to work with. And g of x equals 3x minus 1. So 3x minus 1. So for part A, we want to come in and find f compose g and its domain. So not only do I need to compose the functions, but I also need to address the domain issue. And before I go do that, let's come over to the side and just talk about the domains in general. So for f of x, what is its domain? So f of x is equal to x squared. Does it have any restrictions?
All real numbers.
Yep, beautiful, all real numbers. So negative infinity to infinity. It has no radical, it has no x in the denominator, all real numbers. What about g of x? Same thing? G of x is a line. No radical, no x in the denominator, the domain is all real numbers. Okay, so we kind of need that in a minute, so we're just gonna leave that over there. Okay, so to find f compose g, again, that's f of 3x minus 1. So I'm replacing the g with what g is equal to. So that's telling me to plug 3x minus 1 into f. So that would be 3x minus 1 squared. And I'm fairly sure you have to FOIL that out. Yeah, they're going to want you to simplify your answer. So don't leave it there. Take it the next step. So that's 3x minus 1 times 3x minus 1. Okay, go FOIL that for me and then give me the final answer. So take a second, FOIL it out, tell me what you get.
Nine x squared minus 6x plus 1.
Beautiful. Fantastic. Yay! Good job. Okay, now what's its domain going to be?
All real numbers.
Yeah, so because we don't have any restrictions here, and because this is still a polynomial, it still has no restrictions. So yeah, negative infinity to infinity. So not ugly at all. Okay, and part B, let's go the other way. Let's do g compose f of x. So that would be the same thing as g of x squared. So now I'm replacing the f with what f is, which is x squared. So that would be 3 times x squared minus 1. So I'm replacing my x with the other function. And then this one's easy to clean up. That's just 3x squared minus 1. So nice cleanup. What's its domain? Do I have any
Same.
restrictions? Yeah, the same. Yeah. Good job. Very nice job. Okay, they are also, again, because I cannot pick parts A and B without the other two parts, they're going to ask you to find F compose F and G compose G. Any problem with that?
No.
Is that right? Yeah, F compose F and G compose G. Yep. Okay, the next problem, moving on then. And that's it from 6-1. That's all you've got from 6-1. So, let's find, oh, sorry. So the graph is a 1-to-1 function. I want to graph the inverse. So we have a point over here at -2, -2. Our next point is over here at 0, 1. And our last point is at 3, 6. 1, 2, 3, 4, 5, 6. So it looks something like that. And depending on your grid, it's not necessarily a straight line, but it looks something like that. So -2, -2, 0, 1, and 3, 6. So that's the original function f. And I want to graph its inverse. So this was yesterday's lecture. In order to graph the inverse, what do I have to do?
Switch the X and Y's.
Correct. And that's it. Do not change signs. You're just flipping the order. So we're still going to have the point that's at -2, -2. We'll now have a point at 1, 0. And then the other point is going to be at 6. 1, 2, 3, 4, 5, 6, 3. So over here. So 6, 3. And you'll end up with something that looks like that. That's a 6. So, and that would be F inverse. So the easiest problem on the entire exam is sitting right there. All you have to do is remember to flip the X and Y's, but do not change signs. Okay. Comments or questions about that? The easiest one, I don't remember how much I made it worth. Okay. And the last one I'm going to talk about, number 11. Okay. So the function f of x equals 2 over x plus 1 is 1-to-1. What I want to do is find the inverse. If it is 1-to-1, it has an inverse. I want to know what its inverse is. So, okay, so this was yesterday. There's only 4 steps to the process. So the first step was to replace f of x with y. Do you remember the second step from yesterday?
Switch them.
Yep, switch the x and the y. And that's the actual inverse going on. So wherever there's an x, I write a y. Whenever there's a y, I write an x. Beautiful. And now we're going to solve for the y. So to do that, I'm going to multiply both sides by y plus 1. I'm going to clear the fraction. So you multiply both sides by the common denominator. On the right-hand side, that y plus 1 is going to cancel. You're just left with a 2. On the left-hand side, and you can do this a couple of different ways. I choose to distribute because I think it's cleaner. That is just me. So we're going to do xy plus x. So all I've done is multiplied this x into the y and this x into the 1. And we're solving for y, so let's get this term by itself. So let's go ahead and subtract the x from both sides. We'll get xy equals 2 minus x, and then we'll divide everything by x. So I get 2 minus x over x. And then the last step is the one that most people forget to do, and that's to write that inverse function. notation. So replace the y with the inverse function notation. Okay, and then what they're going to have you do, the question which I find this rather humorous because it's an online. So it says, find the inverse and check the answer. How can you possibly prove that you've checked the answer? So you can't. So I think that's funny. They want you to find the domain and range of both of them and then graph them on the same coordinate system. So it's multiple parts on this problem. So I'm going to go graph them before I go and find the domain and range. No, let's go find the domain and range first because I think you can do that. So, okay, so let's do that. I'll make my same little chart that we looked at yesterday. F inverse, domain, range. Uh-oh, I just did a bad thing. I erased my function without writing it down. Was it 2 minus x over x? Is that right?
Yes.
Yeah.
Okay, good. Don't do that. Okay, so for the original function, it blows up when x is a -1, right? Because in this function, we can't divide by 0, so we have to avoid -1. So negative infinity to -1, and -1 to infinity. So that means the range of the inverse function is going to be negative infinity to -1 and -1 to infinity. Okay, so what about the domain of the inverse function? So notice I'm picking the easier pieces of information to find. So for the inverse function, we know that x can't be 0 because we can't divide by 0. So its domain is negative infinity to 0 and 0 to infinity. So over here, when I flip that, I have negative infinity to 0 and 0 to infinity. So comments or questions? So again, it's easiest to find the two domains and then flip them to get the ranges. So. Okay, I'm going to go graph the original function. So the original function would have a vertical asymptote at -1. So over here at -1. And we said its horizontal asymptote, because it's bottom heavy, is this axis. So sitting on top of this axis. Then other pieces of information, you need the x-intercept. Again, this one's harder than the one you have on the exam. The x-intercept, it doesn't have one because if I set the numerator to 0, I'll get no information. So it's our bow tie function. It's looking like this. So it does this, and then it does this. So that's the original function. So that's f of x. Okay, now the inverse function, right? So has an asymptote at x equal to 0. So I'm going to do it in red. It's sitting right here. And its horizontal asymptote is down here at -1. Yeah. I do have one point on the original graph that's the y-intercept. That point would have been at 0, 1, half. And again, nope, sorry, 0, 2. And I know that because I can come in and quickly replace the x with a 0, and that'll give me 2 over 1, which is 2. So that means the inverse function has to have a point at 2, 0. So 2, 2, 0. And that helps me get stuff drawn in. So then I'm going to do the same kind of bow tie shape over here, and then down in through here. That's a mess. Hope it looks better on yours than it does on mine. So that's the inverse function. Okay, and if they cross, they should cross along the line y equal to x. You'll notice my y equal to x line is not very good because this is not really on it and this doesn't look like it's on it either, but it looks something like that. So again, I chose the harder one on the review. Yours is a much easier one. It's either a cube or a cube root or a square root, much easier to graph. So, okay, and that should be the entire exam essentially. We did 11. There are 2 more of them that are similar to ones we've already done, so that's why we didn't do them. Any comments or questions right now?
Nope.
I'm okay.
Now, are we all clear about what's going to happen tomorrow?